Welcome to the next GeoBoost video with the topic of specialization in shallow geothermal energy. We are in the module 4, dealing with groundwater heat pumps, and in the submodule 4.3, we will tell you something about thermal interference management for groundwater heat pump systems. So what does thermal interference or interaction means? So what we do is, if we inject cold or warm water back to the groundwater body, we induce a thermal plume, which means that the heated or cold groundwater is actually distributed in the underground by the dynamics of the groundwater. And then the groundwater, what we inject back, can flow through the production well. This will be an interaction, or it can flow downstream to other groundwater heat pump systems or drinking water wells. This will be then the interference. Here you see an interaction. So we pump out the warm water or the cold water, depending on for which use you are doing that. And we inject it back. And if the warm water, for example, in cooling issues, flows back to the production well, then we have a so-called thermal recycling. And the production well actually gets then warmer or colder, depending on the system, and then the efficiency can decrease. So this must be, of course, considered in the planning and depends on several issues. Of course, depends on the condition of the underground condition and how you operate your system, of course. So it depends on the volume abstraction rate, so how much do you pump out, and on the flow velocity in your aquifer, and this depends also on hydraulic conductivity and the hydraulic gradient. On the left side, you see if the gradient, if you pump out the water and inject it back, and the gradient is more or less horizontal, you won't see an interaction here. So it is separated, the thermal plume is quite separated from the water which flows through the production well. But of course, if you have other conditions, for example, other hydraulic conditions, so that the distance between the production and the injection well is too low, so that the injected water can flow back to the production water, then your gradient between the wells will be not more horizontal, and some water will flow back to the production. This can be calculated very roughly. So you can calculate what is the needed length between the production and the injection well, depending on your transmissivity, so hydraulic conductivity and aquifer thickness, the hydraulic gradient, and your pumping rate. And in general, in practice, more or less a distance between 10 meters is quite very common. But if you have larger systems, and if you pump out a lot more, you need a higher distance between injection and production well. And if you pump less, you need a less distance, of course. So you can also calculate what is the time needed that you see the interaction of the wells. And this depends also on the flow velocity and on the effective porosity, because these actually controls a little bit the groundwater velocity. And a fact which is quite interesting is that the thermal plume maybe is a little bit slower than the volume, the water volume, which interacts. So you see a hydraulic influence of your wells, but don't see a temperature change in the production well. This is the reason why we have also some storage of the temperature in the underground. So the injected water actually interacts with the rock on the way to the production well again. So it stores actually the heat or cold then in the rocks, and you don't see a thermal change in the production well. So this is called then thermal retardation, and this actually leads that you even if you have a hydraulic interaction, you don't maybe not see a thermal interaction immediately. This is also what you can include in your calculations, but that's normally not so easy. So if you are actually avoid a hydraulic interaction, you avoid a thermal interaction anyway. And to integrate all that in planning, so some distances, or you have to consider some distances. As I said before, so you have to see how much space do we have in the ground. You want to implement a groundwater heat pump, and then you see the production well here with red dots, and the injection well needs a specific distance. Of course, you have to place the injection well in groundwater flow direction, that the thermal plume actually flows away and not directly to the production well. And you need a specific distance, and this distance is also depending on how much space do you have left on your ground anyway. So normally you should not influence it by 1 degree Celsius, something like that. This is quite very common for planning. And of course, you need also to consider other distances for practical reasons. The distance, you should have a distance between your buildings, and also, the distance between production and injection well we already discussed, and also some distances to plants, to plantations, to trees, and so on, because for the planning, it is just important that with your drilling equipment, you can go in the space you want to implement the groundwater heat pump system, and that it is reachable for all the work which must be done.